30th, and we're going to look at multiplying and dividing algebraic fractions. It's the natural follow-on to adding and subtracting algebraic fractions. Just like yesterday, I tried to show you, or 2 days ago actually, I tried to show you you could handle adding them if you could add regular fractions. So what we're going to do today to start out is we're going to remind ourselves that we know how to multiply and divide regular fractions, and then I'll show you that it's the same process. We just have to look at the numbers a little differently. All right, so the first problem we're going to look at is 5/12 times 6/25. When you look at that problem, what's the first thing you think that you need to do? Robbie?
Simplify dividing 5 and 25.
Okay. Simplify before we multiply. It makes it easier. The reason we simplify is because the 5 and 25 have a common factor. What is the common factor they have? Not what they will become, but what's the common factor? Daryl? 5. So I can divide out that common factor of 5, and I'm left with what, Daryl?
You're left with 1 and 5.
Very good. And 6 and 12 have a common factor. What is it, Mary? 6. So I can cancel out that common factor of 6, and what am I left with, Mary?
1.
Very good. Okay, so I think that we've simplified everything we can, right? What do we do now when we multiply two fractions? Liam?
You start from the numerator and you multiply the numerators, so that's 1.
Good.
And you multiply the denominators, and then that's 10.
Very
So you
good.
get 1/10.
1/10. Perfect. Okay, so let's look at the next one. It's division, right? What's the big change here with division? What do we have to worry about? Caitlin?
You have to change it to multiplication and switch the numbers.
Which one do we switch,
The
Caitlin?
second fraction.
And who remembers what that switched fraction is called? Michael? The reciprocal. Good. So what does the problem become, Caitlin?
7/10 times 15/14.
And then it's really similar to the problem we just did, right? Could I have canceled common factors up here before I wrote it as a multiplication problem?
No.
No! Right? You gotta have it as a multiplication problem to cancel, which we're gonna do now. Will, you see any common factors?
Yeah.
Tell me what the common factor you see is.
7 and 14.
What factor do they share?
7.
So we're gonna cancel that out, and what's it gonna become?
1 and 2.
Good. All right, moving on. Anything else? Anna?
7 and 15 share 5.
Good. And when we cancel it, what do we get?
2 and 3.
Very good.
Plus
God bless you.
Bless you.
Anything else left to cancel? Anything else, Mary?
No.
No. I always ask that question to see how you're thinking. When you multiply, what do you get, Mary? 3/4, and we're done. Any questions?
No.
All right, so this is easy, right?
Yeah.
Good. All right, -3/5 squared. Anytime you see a squaring or a cubing or whatever today, you're going to write it out in long form. What does -3/5 squared mean, Caitlin?
-3/5 times -3/5.
Good. And when you multiply those, what do you get? 0?
9.6.
9/26. All right, so this is easy, which is good, because then it should make algebraic fractions easy as well. So we're going to extend the idea to algebraic fractions. Like this.
Whoa.
6y over 22x squared times x cubed over 3y squared. All right. No big deal. Here's the one big thing that's different here, and I mentioned it up there. Anytime you have a variable that's being raised to a power, I want you to write out its factors. Don't write it in exponential form, okay? I will talk to you maybe in the next couple days about changing that once you understand it better. So the first thing I'm going to expect you to do is write this instead of as x squared. What does x squared mean? Luke?
X times X.
Right. 2 factors of x. Write them both out. All right. Times, instead of writing x cubed in the numerator, what does x cubed mean, Will?
X.
3 factors of x. And the denominator, what should I write that as? Anna?
3y.
Right. The reason that we're doing this is it's easier to find factors that cancel, okay? So when you look at this, and you might want to switch to a pen when you do your canceling so it doesn't get too messy. And those of you who are into that current fad of micro writing, you know, writing super small, I discourage you from doing that because it just makes it hard to read. All right. So when we're looking at this, now we need to start looking for common factors we can cancel before we multiply. Does anyone see a common factor in a numerator and denominator that we could divide out? Yeah?
You could divide out 6y and 3yy.
Okay, here's something. Look at each of these factors individually, okay? So how about we just look at the 6 and the 3?
Yeah.
Okay, what's a common factor they have?
They share 2. Or no, 3.
3. Right, they share 3, and when you divide out that 3, the 6 becomes a 2, and this 3 becomes 1. Good. All right. Notice these are not sums, right? This isn't 6 plus y plus 6x. These are all products, times, times, times. So we need to look at each of these factors individually and find ones that divide each other out or cancel out. Keep in mind that an x down here is like the same number up here. If it were 5, there would be a 5 down here and a 5 up here. So thinking about that, what else might cancel? Luke? Okay, we can cancel the 2 and 22. Very important for you to remember that just because it's one on top of the other, we can still cancel it, right? It's like reducing a fraction. What does that simplify to, Luke?
1 over 1 by 11xx.
1 and 11, okay? Anyone see any other common factors between the numerators and the denominators? Logan?
Can't you do xxx, well, cancel out xx, so it would be x on the top and y on the bottom?
Yeah, each of these factors cancel each other out. An x down here will cancel an x out up here. So that cancels. It's like a 5 over a 5. Or 6 over 6, or it might be, who knows, 20 over 20. Robbie?
I was just going to say,
Okay.
you can cancel out the y and 2y out.
Okay, you can cancel 1 for 1.
Yeah.
So 1 factor of y here will cancel 1 factor of y there.
Yeah.
Yeah? Okay. Anything else? Caitlin?
We can do another x.
You can do another x, you see. All right. Anything else? Mikey?
I was just gonna say, if you x out all the entire numerator, there wouldn't be anything to multiply.
There would be. What would be there?
Oh, the denominator.
Well, yeah, but even in the numerator, when I divide out the 2, right, what is left there? 1. So if everything canceled out, it would be a 1 in the numerator. That's a good thing to point out. All right, anything left to cancel? What was the answer for that? Daryl?
No.
No. So now we multiply. What's in our numerator, Daryl?
X.
And in our denominator?
11y.
And that's our answer. X over 11y.
Scary.
No, it's not. But key right now today for this lesson is you to bust out these variable power to writing them out in factored form. It'll help you find the pairs and make it make more sense in your head. Okay? All right. So now the next step, of course, would be this problem. Okay, what's, no big deal here, right? What's the difference, Vaishu?
3 and n, then 2
Squared 2.
and n.
Okay, so she has 2 factors of m and 2 factors of n she wrote out, right? Now what am I going to put here in the middle? Mary? Yeah, and what am I going to do with the second fraction, Mary? Good, so what should I write here? 20m over 9n. Any questions about that? Now what do we look for? What do we look for, Mikey?
Like,
Yep, simplifying, factors, common factors that would divide out. Can you find one, Mikey?
3n and 3.
3 and
9n.
9, okay, and just look at that variable separate from the numbers, what cancels, Mikey? It's the common factor they share.
Oh,
3, and what are we left with?
3.
Down here, and up here?
1.
Good. Other common factors we can cancel. Liam?
You can do 1m, or no, you do 20m and one of the m's, and
Yeah, just, we can't do anything with the 20, but the m here and the
Yeah.
m down there, right? So one of the m's down there. Is there anything else?
No.
Daryl says no. Anyone disagree? Yeah, Mikey?
is it possible to cancel out the n in the denominator with an n from the other denominator?
No, it's only one over the other, and the reason that factors cancel, Mikey, is like if you have a 5 over 5, what is 5 over 5? 1. So when you have something in the numerator and something in the denominator, they divide away to 1. So that's a good question to clarify. You know, one has to be in top and one has to be in bottom. Good question. All right, now we multiply numerator times numerator, denominator times denominator. Will, what do we have left?
You get 20 over m and m times n cubed.
Sure. What would you tell Will? Besides, no, that's not what I got, Robbie. What did you get? Yeah, I think you lost your 3.
Oh.
Yep,
But wouldn't it be m times 3?
it's 3 m n cubed. But Will, tell us how you got n
That's a
cubed.
That's because there's 2 n's in the left fraction and 1 n on the right.
3 factors of n. All right, so it's 3m n cubed left. Anyone have a question about that?
No.
Will?
Why would m also be cubed if you were like to solve that out?
No, this is 3 times m, not 3 factors of m. Good question, that's the thing we gotta keep clarifying. Daryl, did you have something?
Oh, no.
Okay, last one. 3x over 5 squared. So the first thing you do, if you have an exponent, you should write it out long form. What does 3x over 5 squared mean, Jack?
3x over 5 times 3x over 5.
Very good. Let's talk about this. Is there anything we can cancel? Any common factors in numerators or denominators?
No.
Mary? No, there aren't anything. The numbers don't cancel, the variables, there's nothing in top and bottom. When we multiply, what do we get? Robbie?
Get 9x squared over
9x squared over, what's 5 times 5? Good. But what I'm really pleased about is that Robbie caught that x times x is
X
squared. All right. So I'm going to have you start your homework right now.